The FM Taunzu system is a Japanese PC variant, built by Fujitsu from February 1989 to the summer of 1997. It started as a proprietary PC variant intended for multimedia applications and PC games, but later became more compatible with regular PCs. In 1993, the FM Taunzu Marty was released, a gaming console compatible with existing FM Taunzu games. The FM part of the name means Fujitsu Micro, like their earlier products, while the Taunzu part is derived from the code name the system was assigned while in development, Taunzu. This refers to Charles Taunzu, one of the winners of the 1964 Nobel Prize in Physics. Following a custom of Fujitsu at the time to code name PC products after Nobel Prize winners, the E in Taunzu was dropped where the system went into production to make it clearer that the term was to be pronounced like the word Taunzu, rather than the potential Tonez. History. Fujitsu, which had the best-selling 8-bit home computer FM7, and the Fujitsu Micro 16's PC in early 1980s in Japan, decided to release a new home computer after the FM7 was overcome by NEC's PC 8801 computer. From this experience, Fujitsu learned that software sales drove hardware sales. In order to acquire usable software quickly, the new computer was to be based on Fujitsu's FMR50 system architecture. The FMR50 system, released at 1986, was another x86, DOS-based computer similar to NEC's popular PC 9801. The FMR50 computers were sold to moderate success in Japanese offices, particularly in Japanese government offices. There were hundreds of software packages available for the FMR, including Lotus 1, 2, 3, WordStar, Multiplan, and DBase 3. With this basis of compatibility, the more multimedia-friendly FM Taunzu was born. NEC's PC 9801 computers were widespread and dominated in the 1980s, at one point reaching 70% of the 16/32 computer market. However, they had poor graphics and sounds. Just as Commodore saw an opening for the Amiga in some global markets against the IBM PC, a computer with improved graphics and sounds was considered to overcome the PC 9801 in the home use field in Japan. With many multimedia innovations for its time, the FM Taunzu was that system. Though for a number of reasons it never broke far beyond the boundaries of its niche market status. Eventually the Taunzu lost much of its uniqueness by adding a DOS/V compatibility mode switch, until Fujitsu finally discontinued making FM Taunzu-specific hardware and software and moved to focus on the IBM PC clones that many Japanese manufacturers, who previously were not players in the PC market, were building by the mid to late 1990s. To this day, Fujitsu is known for its laptop PCs globally, and FM Taunzu users have been relegated to a small community of aficionados. Details. Several variants were built. The first system was based on an Intel 803860X processor running at a clock speed of 16 MHz, with the option of adding an 80,387 FPU, featured 1 or 2 MB of RAM, 1 or 2 3.5 floppy disk drives and a single-speed CD-ROM drive. It was delivered with a gamepad, a mouse and a microphone. The earlier, more distinctive models featuring a vertical CD-ROM tray on the front of the case were often referred to as the Grey Taunzu, and were the ones most directly associated with the FM Taunzu brand. Most featured 3 memory expansion slots and used 72-pin non-parity SIMs with a required timing of 100 nanoseconds or less and a recommended timing of 60 nanoseconds. Hard drives were not standard equipment, and were not required for most uses. The OS was loaded from CD-ROM by default. A SCSI Centronics 50, SCSI-1, full-pitch port was provided for connecting external SCSI disk drives. and was the most common way to connect a hard drive to an FM Taunzu PC. Although internal drives are rare, there is a hidden compartment with a SCSI 50-pin connector where a hard drive may be connected. However, the power supply module does not typically provide the required Molex connector to power the drive. The video output was 15 kHz RGB using the same DB15 connector and pinout as the PC9801. The operating system used was Windows 3.0, 3.1, 95 and a graphical OS called Taunzu OS, based on MS-DOS and the FireLap-DOS extender. Most games for the system were written in protected mode assembly and C using the FireLap-DOS extender. These games usually utilize the Taunzu OS API for handling several graphic modes, sprites, sounds, a mouse, gamepads and CD audio. A minimal DOS system that allowed the CD-ROM drive to be accessed was contained in a system ROM. This, coupled with Fujitsu's decision to charge only a minimal license fee for the inclusion of a bare-bones Taunzu OS on game CD-ROMs, allowed game developers to make games bootable directly from CD-ROM without the need for a boot floppy or hard disk. To boot the system from CD-ROM, the FM Taunzu had a hidden C-ROM drive in which a minimum MS-DOS system, CD-ROM driver and MS-CDEX were installed. This minimal DOS system ran first, and the DOS system read and executed the Taunzu OS IPL stored in CD-ROM after that. The Taunzu OS CD-ROM had an IPL, MS-DOS system, DOS extender, and Taunzu API. Various Linux and BSD distributions have also been ported to the FM Taunzu system, including Debian and Gentoo. A version of GNU called GNU for FM Taunzu was released in 1990. Graphics. The FM Taunzu featured video modes ranging from 320x200 to 720x512 resolutions, with 16 to 32,768 simultaneous colors out of a possible 4,096 to 16.777 million. Most of these video modes had 2 memory pages, and it allowed the use of up to 1024 sprites of 16 x 16 pixels each. It also had a built-in font ROM for the display of kanji characters. One unique feature of the FM Taunzu system was the ability to overlay different video modes. For example, the 320x200 video mode with 32,768 colors could be overlaid with a 640x480 mode using 16 colors, which allowed games to combine high-color graphics with high-resolution kanji text. It uses 640 kilobytes of video RAM, including 512 kilobytes RAM and 128 kilobytes sprite RAM. FM Taunzu supports the following graphics modes. Bitmap modes. 640x819 virtual at 16 out of 4096 colors. Overlay support with mode 2. 640x819 virtual at 16 out of 4096 colors. Overlay support with mode 1. 1024x512 virtual at 16 out of 4096 colors. Overlay support with modes 5 or 10. 1024x512 virtual at 16 out of 4096 colors. Overlay support with mode 6. 256x512 virtual at 32,768 colors. Overlay support with modes 3 or 10. 256x512 virtual at 32,768 colors. Overlay support with mode 4. 256x512 virtual at 32,768 colors. Overlay support with mode 9. 256x512 virtual at 32,768 colors. Overlay support with mode 11. 512 times 256 virtual at 32,768 colors. Overlay support with Mode 7. 512 times 256 virtual at 32,768 colors. Overlay support with modes 3 or 5. 512 times 256 virtual at 32,768 colors. Overlay support with mode 8. 1024 times 512 virtual at 256 out of 16,777,216 colors. Overlay not supported. 1024 times 512 virtual at 256 out of 16,777,216 colors. Overlay not supported. 1024 times 512 virtual at 256 out of 16,777,216 colors. Overlay not supported. 512 times 512 virtual at 32,768 colors. Overlay not supported. 512 times 512 virtual at 32,768 colors. Overlay not supported. 512 times 512 virtual at 32,768 colors. Overlay not supported. 512 times 512 virtual at 32,768 colors. Overlay not supported. Sprite layer. Resolution 256 times 240 pixels. Colors 256 on screen out of 32,768 palette. Sprite RAM 128 kilobytes. Maximum sprite count up to 1024 on screen. Sprite size 16 times 16 pixels. Colors per sprite 16. Overlay support. Bitmap modes 1 to 11. Up to 2 graphical layers can be overlaid, whether it is 2 bitmap layers, or the sprite layer with a bitmap background layer. The latter is useful for action games, though the sprite function is not as advanced as that of rival 16-bit computer, the Sharp X68000. When the sprite layer is used, it is rendered to VRAM layer 1 on top, with the bitmap background as VRAM layer 0 below. When 2 bitmap layers are used, then both are rendered to VRAM layers 0 and 1. CPU. The following is a list of models and the CPUs they contain from the factory. 80386SX. UX, Marty, Marty 2, Car Marty. 80386SX. UG, 80386DX. CX, 80386DX. HG, 80486SX. HR, 80486SX. Me, 80486SX. MA, MF, Fresh, Fresh TV, Fresh T, each, 80486DX2. MX, Fresh E, Fresh S, Fresh ET, HA, 486DX4. Fresh FS, Fresh FD. Pentium, HB, Pentium, HC. Sound. The FM Taunzu system was able to play regular audio CDs, and also supported the use of 8 PCM voices and 6 FM channels, thanks to the Ricoh RF5C68 and Yamaha YM2612 sound chips, respectively. The system had ports in the front to accommodate karaoke, LEDs to indicate volume level, and software to add popular voice-altering effects such as echoes. Games on the FM Taunzu regularly used Redbook orchestral music tracks, especially if they were designed specifically for the Fujitsu system. This was a novelty and innovation far ahead of other PCs of the time, made possible by the standard CD-ROM drive in every FM Taunzu computer operating system. The FM Taunzu was capable of booting its Taunzu OS, a graphical OS, straight from CD in 1989. 2 years before the boot from CD-capable System 7 was released for the Macintosh. and a full 7 years before Windows 95 BOSR2 was released for IBM PC compatibles.